My dear students, welcome back to our channel. In this video, I will be explaining the B.Ed second semester subject content and pedagogy of physical science education at secondary stage, as prescribed by Osmania University and other universities of Telangana. We will go through the important questions and answers one by one. Let's begin with a quick revision. Unit 1 first important short question is: define curriculum and syllabus. In education, curriculum and syllabus are two related but different terms. Curriculum is the overall plan of education. It includes everything that a school provides to help students learn and develop. It not only covers subjects like physics, chemistry, and biology but also co-curricular activities, teaching methods, values, skills, and even the experiences that students gain in school. Example, in physical science, the curriculum may include topics like laws of motion, experiments, lab work, field visits, and projects to build scientific thinking. Syllabus, on the other hand, is a specific list of topics to be studied in a subject within a fixed time, like one semester or academic year. Example, a physical science syllabus for class 9 may include chapters such as force and motion, work and energy, and sound. Easy tip. Curriculum is equal to big picture, what, why, how of education. Syllabus is equal to detailed list, what to study in a subject. Next important short question is: 2. What is Dale's cone of experience? Dale's cone of experience. Dale's cone of experience was given by Edgar Dale to show how people learn better through different types of experiences. It is shaped like a cone, triangle, and explains that the more direct and active the experience, the better the learning. At the top of the cone are abstract methods like reading and hearing words. These give the least retention. In the middle, there are visual methods like pictures, models, and demonstrations. These improve understanding. At the bottom of the cone are direct, hands-on experiences like experiments, real-life practice, and field work. These give the highest learning because students use all senses. Example, in physical science, if students only read about magnetism, they may forget soon. But if they perform an experiment with magnets, they will remember longer. Easy tip. More active participation is equal to more effective learning. Next important short question is: 3. Write any 2 recommendations of NEP 2020 for science curriculum. 2 recommendations of NEP 2020 for science curriculum. The National Education Policy, NEP, 2020 has given many suggestions to make the science curriculum more practical and student-friendly. 2 important recommendations are: 1. Hands-on and experiential learning. Science should not be taught only from textbooks. Students must do experiments, projects, and activities to understand concepts. Example, instead of just reading about Newton's laws, students can perform small experiments with balls and trolleys to see the laws in action. This makes learning fun and long-lasting. 2. Integration with technology and real-life applications. NEP 2020 recommends using digital tools, simulations, and local examples to link science with daily life. Example: while teaching renewable energy, teachers can show solar panels in the school or nearby homes, making students connect classroom knowledge with real society. Easy tip. NEP 2020 wants science learning to be practical, technology-friendly, and connected to real life rather than just memorizing facts. Next important short question is: 4. Mention 2 merits of constructivist approach in curriculum development. 2 merits of constructivist approach in curriculum development. The constructivist approach in education believes that students learn best when they build knowledge themselves instead of only listening to the teacher. This method gives many advantages. Two important merits are: 1. Active and meaningful learning. In constructivism, students are not passive listeners. They explore, discuss, and discover concepts on their own. Example, instead of only explaining electric circuits, the teacher allows students to make a small circuit with battery and bulb. This helps them truly understand the concept, not just memorize it. 2. Improves problem solving and creativity. Students face real-life situations and try to find solutions. This develops critical thinking and creativity. Example, while learning about pollution, students may suggest ideas for reducing plastic waste in school, which makes learning practical and useful. Easy tip. Constructivist curriculum makes students think, explore, and apply knowledge in real life, which is more powerful than rote learning. Next important short question is: 5. List any to-print resources used in science teaching. To-print resources used in science teaching. In science education, print resources are materials in written or printed form that help both teachers and students in learning. Two important print resources are: 1. Textbooks. Textbooks are the main source of structured knowledge. They explain concepts, give definitions, diagrams, and solved examples. Example: a physics textbook may explain laws of motion with Newton's laws, real-life examples like moving a cart, and practice questions. Textbooks act as a guidebook for both teacher and student. 2. Science magazines and journals. Magazines and journals provide updated knowledge and interesting facts beyond the textbook. They include experiments, discoveries, and real-life applications of science. Example, a science magazine article on Chandrayaan-3 mission can make students curious and connect classroom learning with current events. Easy tip. Print resources like textbooks and magazines build a strong base of knowledge and also spark curiosity about the latest developments in science. Next, Unit 6. Long questions. First important long question is: 1. Explain the history and development of curriculum framework in science. History and development of curriculum framework in science. The curriculum framework in science has gone through many stages of growth in India. It reflects the changes in society, education policies, and the needs of students. The main goal has always been to make science meaningful, practical, and connected to life. 1. Early period, before independence. During British rule, science was taught mainly as theoretical knowledge. It was introduced to produce clerks and workers, not innovators. The focus was more on memorization than understanding. For example, students had to learn definitions of electricity but had little chance to do experiments. 2. Post-independence period. After 1947, India wanted a strong education system to support development, industry, and technology. The Radhakrishnan Commission, 1948, and Mudaliar Commission, 1952, suggested making science compulsory at the secondary stage. This was the first big step to encourage scientific thinking among all students. 3. Kothari Commission, 1964-66. This was a turning point. It recommended the 10+2+3 structure and stressed that science must be taught as a way of inquiry, not just facts. Practical work, experiments, and linking science with society became important. 4. National Curriculum Framework, NCF. The National Council of Educational Research and Training (NCERT). Prepared for NCFs. NCF 1975 emphasized environmental awareness and practical work. NCF 1988 focused on making science child-centered and activity-based. NCF 2000 added ICT, computers, internet, and stressed learning science through projects and applications. NCF 2005, most influential, it suggested learning science through experiments, inquiry, and real-life problems. For example, instead of only reading about water pollution, students could test water samples. 5. NEP 2020 and beyond. The National Education Policy 2020 recommends a flexible, multidisciplinary curriculum. Science should be taught through experiments, critical thinking, and integration with technology. It also promotes coding, robotics, and environmental education, preparing students for modern challenges. Conclusion. The history of the science curriculum shows a journey from rote learning to activity-based, child-centered learning. Today, the focus is on making students curious problem solvers who can use science for the betterment of society. Easy tip: remember the flow. British period post-independence commissions NCFs 1975, 1988, 2000, 2005, NEP 2020. Next important long question is: to discuss the shift from subject-centered to behaviorist to constructivist approaches in curriculum development. Shift from subject-centered to behaviorist to constructivist approaches in curriculum development. The way curriculum is designed has changed over time, moving from subject-centered to behaviorist and finally to constructivist approaches. This shift shows how education has become more student-friendly and activity-based. 1. Subject-centered approach. In the early days, the focus was mainly on subjects or content. The aim was to fill students' minds with facts and theories. Teachers were the authority, and students just listened and memorized. Example: in science, students were asked to memorize Newton's laws without real-life applications. Weakness: students knew definitions but could not apply them in real situations. 2. Behaviorist approach. In the mid-20th century, inspired by psychologists like B.F. Skinner, curriculum shifted to behaviorist principles. Learning was seen as a change in behavior due to stimulus and response. Rewards and punishments were used to motivate learning. Example: in a physics class, students solving problems correctly were praised or given marks as rewards. This approach was more systematic and measurable than subject-centered, but still limited creativity. 3. Constructivist approach. Modern education now follows the constructivist approach, based on the ideas of Piaget and Vygotsky. It believes students construct knowledge on their own by doing activities, experiments, and discussions. The teacher is a facilitator, not just a lecturer. Example: instead of memorizing about acids and bases, students perform experiments with litmus paper and discover the concepts themselves. This makes learning meaningful, long-lasting, and connected to real life. Comparison and shift. Subject-centered focus only on content. Behaviorist focus on behavior change through rewards punishments. Constructivist focus on active learning and problem solving. Conclusion. The shift shows the journey from teacher-dominated to student-centered learning. Today, the constructivist approach is preferred because it develops curiosity, creativity, and critical thinking, which are essential for science learning and modern life. Sparkle's easy tip: remember the shift as facts, behavior, understanding. Next important long question is: 3. Explain the recommendations of NCFSE, 2023 for Science Curriculum. Recommendations of NCFSE 2023 for Science Curriculum. The National Curriculum Framework for School Education, NCFSE 2023, prepared under the NEP 2020, gives clear guidelines to make science teaching at the secondary stage more interesting, practical, and student-friendly. Its recommendations focus on building skills, creativity, and real-life application. 1. Focus on conceptual understanding, not rote learning. Science curriculum should avoid only memorizing formulas and facts. Instead, students must understand concepts through activities, discussions, and projects. Example, instead of memorizing Ohm's law, students can measure current and voltage in a circuit and see the relationship themselves. 2. Integration of experiments and hands-on learning. Science should be taught by learning by doing. Every topic should include lab work, field visits, and demonstrations. Example: learning photosynthesis by observing plants in sunlight and shade, not just reading the equation. 3. Use of local context and everyday examples. Curriculum should connect science to local culture, environment, and problems. Example: teaching about water purification using simple filters made at home, which also solves rural drinking water issues. 4. Interdisciplinary and skill-oriented approach. Science should not be taught in isolation but linked with math, technology, and social issues. Example: climate change can be explained using geography, weather, chemistry, greenhouse gases, and economics, impact on farmers. 5. Encouraging critical thinking and inquiry. Students should ask why and how questions instead of just accepting facts. Teachers act as facilitators to guide exploration. Example: instead of telling why the sky looks blue, the teacher encourages students to experiment with light through a prism. 6. Use of technology and digital resources. ICT tools, simulations, and videos should be used for abstract concepts. Example: 3D animations to explain the structure of the atom. Conclusion: the NCFSE 2023 recommends that science education should move from memory-based learning to activity-based, critical, and creative learning. The aim is to make students curious problem solvers who can apply science in real life and contribute to society. Easy tip: remember the 5 keywords: concepts, experiments, local, skills, inquiry, CELSI. Next important long question is: 4. Describe the role of teacher as a curriculum developer with examples. Role of teacher as a curriculum developer. A teacher is not just a person who delivers lessons, but also an active curriculum developer. At the secondary stage, especially in physical science, the teacher plays a very important role in shaping what and how students learn. 1. Interpreter of curriculum. Even though curriculum is framed at the national or state level, teachers bring it to life in the classroom. Example: if the syllabus says heat and its effects, the teacher decides whether to teach it through experiments, stories, or real-life examples like a pressure cooker or desert climate. 2. Designer of learning experiences. Teachers design activities, experiments, and projects that make science meaningful. Example: instead of simply teaching the formula of speed is equal to distance time, the teacher may conduct a race in the playground and ask students to calculate speed themselves. 3. Adapter to local context. Every school and community is different. Teachers modify the curriculum to suit local needs. Example: in a coastal area, a teacher may use fishing boats to explain the concept of buoyancy, while in rural areas, bullock carts can be used for explaining motion. 4. Evaluator of students' learning. Teachers also develop methods to check how well students understand. This includes tests, quizzes, group discussions, or project work. Example, after teaching electricity, a teacher may ask students to make a simple working torch with wires and a bulb. 5. Guide and innovator. Teachers innovate by using technology, storytelling, or models to make lessons exciting. Example, using a smartphone sensor to measure sound levels in the classroom while teaching sound. Conclusion. The teacher acts as a bridge between the written curriculum and the learner. They interpret, adapt, and enrich the syllabus according to students' needs. Without teachers, curriculum remains only on paper. With their creativity, students gain not just knowledge but also skills, curiosity, and confidence to apply science in daily life. Memory tip: remember the 5 roles of a teacher in curriculum development as B.Ed is equal to interpreter, designer, evaluator, adapter, guide. Next important long question is 5. Explain the importance of contextualization of content in science teaching. Importance of contextualization of content in science teaching. Contextualization means teaching science by linking it with the real-life situations, culture, and environment of students. It makes science more meaningful, interesting, and easier to understand. Instead of teaching abstract theories, the teacher connects them to the learner's daily experiences. 1. Makes learning meaningful. When content is related to real life, students easily grasp concepts. Example, teaching pressure by discussing why camels' feet are broad or why sharp knives cut better than blunt ones. 2. Improves retention and understanding. Students remember better when concepts are taught with familiar examples. Example, while teaching evaporation, using the example of clothes drying under the sun instead of only textbook definitions. 3. Bridges gap between theory and practice. Contextualization helps students see how science is applied in daily life. Example, explaining Newton's third law with the action-reaction in rowing a boat or flying a rocket. 4. Encourages curiosity and problem-solving. When students see the use of science around them, they ask more questions and try to solve problems. Example, while learning about electric circuits, students can check why a bulb at home is not glowing and relate it to the classroom lesson. 5. Supports inclusive learning. Every student comes from a different background. By connecting examples from local culture, food, transport, and festivals, all students can relate to the lesson. Example, explaining reflection of light using mirrors in a dressing table or water in a pond. Conclusion. Contextualization makes science alive and student-friendly. It moves learning from bookish knowledge to living knowledge. When students see science in their kitchen, playground, or market, they not only understand better but also develop confidence and interest in the subject. Memory tip: remember benefits of contextualization as mix is equal to meaningful, improves retention, relates theory to practice, curiosity, supports inclusion.